Hi, so this is again the second lecture of week 12. Mostly we will be talking about improving land capability. So, in the first lecture we talked about land capability classification. So, once you classify the lands, so some lands are, if you see arable lands, non-arable lands. So, and also first class is okay, the class number 1, and if you go for class number 2, 3, 4, you may have to start using the soil conservation measures. So, and how to improve the land capability using some measures, we are going to discuss this in this lecture. So, as I said, maybe let's go here. So, the course content is week 12, again repeating this, the first one, land capability classification we finished, and this is lecture number 2 of week 12. We are going to talk about improving land capability, and followed by the other lectures we will be seeing in the next few classes. So, here the collection of information for land capability classification. So, what kind of information really required to classify the land, so that we can put the particular land under class 1, class 2, class 3, so something like that. So, here the information we required here is the soil survey. Basically this is very important, soil survey map. So, that provides information for land capability classification, such as soil series, this is also you can get from a soil survey, and soil taxonomy, and then texture, effective soil depth, land slope, infiltration characteristics of the particular land, and then hydraulic conductivity, erodibility, and wetness. So, how I mean whether this soil will be capable of holding the soil moisture or not, and water logging condition, where the soil has a problem with water logging, and the salinity has the problem of the land or not, and the climate and other details. So, see all these things, once you get the information, you can classify the main class and then the subclasses. So, the soil survey map is very important, and you can get all the information from using the soil map as well as some other survey maps. So, then the next is so what is land capability and how can it be improved. So, land capability we defined in the previous lecture. So, basically the land capability is whether the particular land is capable for growing crops or not. So, basically, so how can it be improved, the class 2, 3, 4 or even following classes, mostly I am talking about arable lands here. So, how can we improve the land condition for crop crop growth. So, basically the 4 common practices, the irrigation, erosion control, drainage and farming. So, the irrigation basically helps in, so irrigation in the sense the giving water to the plant artificially. So, that is the for beneficial use of crop growth basically. So, once you give irrigation or irrigating a crop, so definitely you are wetting the soil root zone, right, and that definitely will improve the soil condition and also improve the macro or micronutrients availability, and also the biological condition or biological biota, we can say the soil biota will improve. Okay. So, then definitely the erosion control measures will control the soil movement from the surface, and the drainage will help in free drain of water from the top to the root zone, and the farming definitely will help in making the nice grade of land, because that is very important, that will give the efficiency of irrigation or improve the not only water available to the crop, but also nutrient availability will improve if you can maintain a good grade of the land. Okay. So, then next is we are going to see one by one. So, the erosion control here So, basically this is excessive erosion may result in land that is no longer fertile. The long term productivity of land can be assured by controlling soil erosion. So, we will be using definitely the soil control soil conservation measures. So, in case of gully control structures, and then terracing, burns, right, all these things definitely will help in reducing the soil movement from the fertile lands to the outside of the land. Okay, so the next is the land drainage. So, land drainage basically the surface drainage, removing water from the surface of the land. Generally ditches and terraces are most often used for this purpose. Okay. And then there is the internal drainage. So, this is the surface and this is all subsurface drainage, we can say it's removal of water within the soil profile. Basically the tiles or tubes installed below normal plowing will be used in this case of subsurface drainage or internal drainage, we can say. So, surface drainage removes the surface water, whereas subsurface drainage removes water from the root zone. Definitely this will be helpful in removing the salts from the root zone. So, the next is the land forming. So, land forming is very important. This is basically smoothing or reshaping of the land to enhance the use of the land for cultivation. So, here a small dips are filled with high places or taken down, because if you have like some small depressions here. So, the shaping will definitely refill the the depressions, and so that definitely helps in. So, what happens if there is a depression here? So, more water content. So, here the moisture content will be more here and the less here. Okay. So, that kind of non uniformity can be avoided in case of properly graded lands. So, typically the land forming involves using a laser guided equipment to assure the good surface. So, here if you see laser guided equipment. So, this is a tractor, so which shapes the land, and here this is the laser guide. So, it guides the tractor where to remove the soil, excess soil, and where to add that excess soil. So, that the desired grade can be achieved. And then capability factors, if you see the capability factors or the characteristics of the land that determine its best crop or alternate use. So, the capability factors are, for example, surface characteristics, the surface texture, erosion, slope, and surface runoff. So, these are all the factors which defines the land capability, and this is all surface characteristics like textures and erosion, all these things. Subsurface characteristics are such as internal drainage, subsurface drainage, and then soil depth. So, we are going to see these capability factors, and then first if you see the soil texture is the proportion of sand, silt, and clay in the soil in a horizon, because since we are talking about the crop production. So, mostly we will be concentrating on a horizon, because that is fertile land and used for crop production, and soil can be classified as either coarse sand and moderately coarse, for example, sand and loam mix, and medium. So, that is a loam, and moderately fine, that is a clay and loam mix, and fines are like clay particles. So, here the based on the soil texture, the soil can be classified as coarse sand, coarse, moderately coarse, medium, moderately fine, and fine based on the different soil textures. And then internal permeability. So, internal permeability this is also called as internal drainage, and soil permeability is the movement of air and water through the soil. So, soil permeability is the property of a media. So, it represents the easiness of a particular like air and water pass through soil matrix. So, it determined by the texture and structure of the soil, and it can be classified as very slow, slow, moderate and rapid. So, the permeability, the internal permeability. So, based on the internal permeability, soils are classified as very slow soils and slow soils, and moderate soils and rapid flow soils. Because the flow is rapid, if the flow is rapid, and we can say the soils are rapid, moderately rapid, okay, or very slow. So, the based on the permeability. Okay, so, the next is permeability classes are like permeability class very rapid. So, mostly the rate of water flow in this class is greater than 10 inches per hour. So, similarly very slow, it will be less than 0.05 inches per hour. Okay. So, you can go through these numbers. These numbers are very helpful when you talk about particular the land class based on the permeability. So, if you knowing the particular permeability range, you can put them in a particular class. Okay. And then the next is the soil horizon. So, soil horizon A, B, C, so something like that, O horizon. So, all classes based on that, the soil depth is basically here. Soil depth is the thickness of the soil layers that is important for crop production. So, for example, the classifications based on the soil depth is very shallow or shallow and moderately deep and deep and very deep soils. So, here the previous lecture we already talked about the soil classes based on this. So, the symbol D1 is for example, land capability classification 5. So, the shallow it seems the very deep class. So, this is the class number 1 is a very deep and then deep soil, moderately deep, shallow and very shallow. So, the classes are here and the symbols are we mentioned in the previous lecture. So, the depths basically we are talking about less than 7.5 all these things. So, knowing the particular depth we can put them in a particular class here. And then soil erosion. Soil erosion is another factor you can see. So, soil erosion is the loss of topsoil by water or wind or by any other forces. So much of the fertility of land is in the topsoil. Okay. So, since we are talking about fertility, so we focus on topsoil. So, that is important for cultivation, and there are 4 categories of erosion we use. The first one is very severe erosion. So, mostly the gullies. So, I mean very severe erosion means the soils are steep, I mean the lands are very steep, and mostly you see in the class the last class 7, 8, and severe erosion and moderate erosion and non to slight erosions. Okay, these under these classes we can put based on the particular erosion factor. Sorry. So, the next is erosion categories. If you see, so non to slight erosion generally is 0 to 25% of the original topsoil is removed. So, if the original topsoil is removed like 0 to 25% of original topsoil is removed, then we can put them under non to slight erosion category. And if it is moderate erosion, so that is 26 to 75%, and the severe erosion, so that is 76%, and very severe erosion, so more than one uncrossable gully present. Suppose if there is a gully here, so this is that means one gully you can say. So, this is difficult to cross, right. So, I mean in order to cross, so if this is the gully, it is difficult to cross. So, at least if it is more than one crossable gully presents, right, more than one gullies, then it is a very severe erosion. So, or if it is 76% of the original topsoil removed or one crossable gully present, one uncrossable gully present, then it is a severe erosion. Okay. So, like that we can describe the erosions into different classes. And the next is the slope. So, slope is the rise and fall in the elevation of the land. So, the slope is I mean depression and elevation. So, measured in percentage, and the number of feet rise and fall in 100 feet. Suppose in 100 feet, so what is the rise, maybe the x rise, okay, or maybe the fall, okay, y fall. So, x by 100 in percentage you get the slope. So, the 6 classes of the land slope are commonly used: very steep slope, strongly sloping, and moderately sloping, gentle sloping, and nearly level slope. Okay. So, based on this, based on the slope, the land can be classified. Okay. Let us see the different numbers here. So, nearly leveled 0 up to 1 foot of the slope in 100 feet. So, 1 foot divided by 100. So, that will be 0 point 0.01. So, that is 0.01. So, that will be about 1% slope, right. So, this is 1% slope. Okay. So, similarly, gentle slope 1 to 3 feet slope in 100 feet. Moderate slope over 3 feet of slope up to 5 feet in 100 feet. Okay. So, then strong slope over 5 to 8 feet in 100 feet. Very steep slope greater than 15 feet in 100 feet. Okay. So, that means, in over 100 feet there is a 15 feet rise you can see in case of very steep slopes. Okay. So, this classification, and then the next is the surface runoff. So, surface runoff is the water from rain, snow, other precipitation that does not soak into the ground. So, whatever abstractions is done, so the amount of water which is running off from the field and which is a part of precipitation is called the runoff, and the amount of runoff depends on the soil texture definitely. So, the sandy soils, definitely the abstraction will be more, that means infiltration will be more, and you will see the less runoff, and the slope of the land, increasing slope definitely increases the water flow and then increases the runoff. So, the categories of surface runoffs are very slow, slow and moderate and rapid. So, based on the runoff class, based on the runoff, the soils can be classified. So, very slow, the soils are having very slow runoff, and slow, the soils are having slow runoff, and moderate, the soils are having moderate runoff. So, like that. So, let us see the categories based on surface runoff. So, very slow, so that is about 0 to 1 feet of slope on coarse soil. The coarse soil, what happens, there is the interstitious the spaces, interstitial spaces are larger. So, definitely the water will pass through the soil very easily, and so that is why the down very easily it will go, whereas the runoff will be very slow because of that. That is why we call these soils definitely the runoff in case of coarse soils is very slow, and whereas in other texture soils which has slope from 0 to 1, that is called slow, and 1 to 3 feet slope in any texture we call moderate, and over 3 feet of slope on any texture we call a rapid. So, you see the rapid runoff in case of the soils having more than 3 feet of slope, that means more than 3% slope we can say, or any other texture. So, irrespective of any texture. So, the slope is basically the good player in deciding the runoff. So, in this lecture mainly we focused on the land capability, what is the land capability, and then how to improve the land capability using irrigation and using the drainage, and then and also the land farming, right, land farming. So, it is very important, and then so based on that there are some factors we discussed on land capability, and then based on the permeability, based on the slope, based on the runoff, texture and the soil depth. So, we decided or discussed the how the land classes can be called. Okay. So, thank you so much for lecture 1 and lecture 2 of this, mostly the land capability classifications, and the following lectures we will be talking about sediment transportation, and then the measurements, the devices used to measure sedimentation, and then I mean erosion, our soil sampling and other stuff. So, thank you so much.